Hey, it's me again, and we are going to do some math. We are going to do solving systems by substitution because we learned how to do them by graphing. Not always the most efficient way. Sometimes it's tricky to graph, and if they didn't cross at perfect whole numbers, it would be really hard to read the graph and figure out if it's crossing, at a third or a fourth or 7/11ths or whatever it's going to be. So we also want some like mathy methods for finding those x, y points that work in both equations, because a system again is going to be like more than one equation. I can't write. So you have more than one equation you're trying to solve simultaneously. And so again, when it says to find the solution, you're looking for an x and a y that makes both equations true. So these are the steps you're following to do substitution. Of course, graphing was named graphing because you're graphing. Substitution is named substitution because you're substituting. You are replacing something with its equal. You cannot solve an equation if it has two variables. Like if there's both an x and a y in it, you can't do it. So you have to get the equation to have one letter in it. It can be x's, it can be y's, but it has to be just one letter. So what you're going to try to do here when it says solve one equation for x or y, it means that you're trying to get like x equals something or y equals something, because that will mean that you can replace x with this stuff or you can replace y with this stuff. So then you're going to substitute whatever you got into the other equation so that you're using both. And then you're going to plug your answer in to get the other variable. So at this point, you will solve. So you'll either know x and need to find y, or you will know y and need to find x. And once you know one, you can plug it in to find the other. So those steps really only make sense if you already know how to do it. So let's walk through those steps together with some examples. Now, you don't always have to do work to get x or y alone, because for example, this one is y equals 2 minus x. There already is one alone. What that means is that y is the same as 2 minus x. So in this second equation, where there used to be a y, I'm going to put a 2 minus x. Now in this problem, the parentheses are kind of meaningless because there's nothing in front, but sometimes there is. So I like to put them there to kind of think it through. And now I can go ahead to the next step and solve just like you have been since Algebra 1. I'm going to collect the 2x minus x, just have 1x plus 2 equals 3, and I'm just going to keep solving. So what I know now is that x is 1. Now you don't always find x first. Sometimes you find y first. So pay attention to whether it belongs in the first or second spot of your answer, because you could solve this by graphing and see where they cross. But we're learning to solve them by a math method instead. Now that I have x, I can go back and plug it in to find y. And you can plug it in wherever you want, but it will be easier to plug it into this place where the y equals was alone, because then I simply put the 1 in where there used to be an x, and I actually find out that y is 1 as well. And then just like with graphing, you can check. I'm going to put a 1 in for the y and a 1 in for the x. That is true. Bottom equation, I'm going to put in a 1 for the x and again for the y, and 2 plus 1 is 3, also true. So it's possible for me to check my answers on all of these problems. Okay, same thing here. I already have here that y is the same as 4 plus 2x. So I go to the other equation, and where there used to be a y, I substitute in the thing that y is equal to, which is the 4 plus 2x. And then we're right back to chapter 1 solving. I need to distribute this 2. And I'm going to combine these like terms and just kind of continue on my way solving. And hopefully the solving aspect isn't giving you too much trouble, because this is something we've been doing for a super long time. So here I got -1, and again, I happen to solve for x first. So that goes in the x place. Now when I got to figure out what y is going to be, this is my easiest one. I could plug it into the top, but this is the easier one because this is going to tell me that straight up that y is equal to 4 plus 2 times whatever I just got for x. So that's going to be 4 minus 2, and then obviously that is 2. And if you really, really, really want to know if it's right, you're going to take each of these and check them. I'm going to put a -1 in for x and a 2 in for y and see if it equals 1. That'd be -3 plus floor, not 4, floor, 4, whatever. And I got 1. Now I'm going to check it in the bottom equation. So I put a 2 where the y was and a -1 where the x is. So 2 equals 4 minus 2, which it does. So I can check and make sure that this is the proper solution. Now, if you did go back and graph them, you would get the same answer. We're not doing something totally different. We are just doing a different method for finding those answers. Now here we have x alone, but that's different. So instead of having y alone, we know what x can be replaced with. So we're going to substitute in where there used to be an x, this stuff that they're telling us x is the same as. And so, I have from that top equation, I have 4, and then I put in my substitution for x, plus 3y equals -2. So now I have one equation with one variable, and I'm going to go ahead and solve it like Algebra 1. Distribute. Combine these because they're on the same side. Add my 36. And I'm going through this part quickly because it is something that we should probably just know how to do by now. And then divide out my -17. Now be careful, here you get y is -2, which is totally fine. But out of habit, a lot of kids will put that in the x spot because they found it first. But it's the y value. That's also important when you go to plug it in, because you want to make sure that you plug that value in for y in order to find the x. So I'm going to put that -2 where the y was. These will cancel out and become a positive 10 minus 9, so x has a value of 1. And like always, I can check my answers by going back to my original equations and putting a 1 where there was an x and a -2 where there was a y. That would be 4 minus 6, which is indeed -2. And you can still use your calculator if you don't feel that confident about checking the numbers. And in the second equation, where there was an x, I put a -2, and where there was a y, I put a 1. So -2 equals, oh, wait, sorry. I did exactly what I told you guys not to do. Just kidding. I'm going to put an x, a 1 in for x, because this is my x and y, sorry about that, and then equals -5, and then my y is -2. Sorry about that, I flip-flopped those. So then I would get 1 equals 10 minus 9, which it does. So then I am confident that these are my proper answers. So for our next quiz, test, whatever it's going to be, that would be a great way to figure it out. This one's kind of weird. So let's take a look. Y is the same as 3x plus 2. So in the other equation, I actually can put 3x plus 2 where the y was, and it's going to have to equal 3x minus 2. So this one gets a little bit weird, because if I just started solving, I would normally move my x's all to one side, but when I do, they're gone, and I get a number statement. So let's talk about that. When we were doing graphing, there were 3 scenarios. In the first scenario, you drew a line, you drew another line, they crossed, and that was your one solution. Or you drew a line, you drew the other line, they were parallel. So if they cross, you get one solution. If they don't cross, we call that parallel, thanks geometry. But that means there's no solution because they don't have a point in common. And then the third option was you draw a line and then you draw a line and they actually end up being, so line 1 ends up being the same as line 2. and they share every single point in common. And so we call that IMS, meaning infinitely many solutions. There are an infinite number of right answers because there are an infinite number of shared points. Okay, so how does that play out when you do these using math instead of graphs? Here I have a statement that is never true. It is never true that 2 equals -2 because they're not equal. That is the way that the math ones show that there are no solution. So there's no solutions to this because I ended up with a number statement that just was not true. If I had done the same math and the x's had disappeared and I got a number statement, but it was always true, so let's pretend. So if you were doing your work, blah, 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 and you got something like 0 equals 0, well, that is always true. And so that would indicate that if you drew those, they would be the same line and you would have infinitely many solutions. Here, where there's no solution, it means that if we drew those, they would be parallel, which actually, if I look back at it, makes sense because they both have the same slope and parallel lines have the same slope. But one starts at -2 and goes up 3 over 1, up 3 over 1, and one starts on the y at +2 and goes up 3 over 1, up 3 over 1. So they're never going to touch. And so that all makes sense, but I just want you to know that when you get these weird number statements and your x's disappear, it's either a false statement that is never, ever, ever true. Sorry about that. And if it's false, it's never true, and you have no solutions because the lines must be parallel. But you didn't graph them, so you can't see that. If you're doing your problem and the x's disappear and you get a number statement that's always true, like 0 equals 0, 5 equals 5, that's always true. So that would be an indicator that they are the same line and you have infinitely many solutions. So hopefully that helps you tackle day 1 of 3-4.